Here we go. 7A. So we're going to split this one up. Exponential growth and decay is what we are talking about today. This is going to feel very similar to what we were doing. But I'm going to show you this new element that comes into play. And I realized I really didn't even put the new equation in that I wanted to, but I will show you as we go. So exponential growth is something is growing exponentially. So it's that whole shoot up real fast type thing where it starts slow and then all of a sudden, it's exponential. So we looked at this function yesterday, a times b to the x, where a is greater than 0 and b is greater than 1. This b number, that's called your growth factor. It's what you are growing by. So if that number is a number greater than 1, which is what they're saying here, b will be greater than 1 when it is growth, then that thing is increasing. So like if it's 2, it is doubling, right? If it's 1.25, what's 1.25 as a percent? It's 125%. 1.25. So it's 125% of what it was. That means it is growing, okay, 1.25. So that's what we're going to be looking at. This A will always be your initial or your starting amount, okay? This B will always be your growth factor, which for growth is going to be greater than 1. And then your exponent, this is usually the time portion of whatever it is we're talking about, okay? So as long as you know what goes where in these are not terribly challenging. If you don't understand what goes where, it's not gonna work out as nicely. So first of all, let's just take a look at these and see what we've got. Okay, it says identify the initial amount A and the growth factor B in each exponential function. So if my equation is y equals a times b to the x power, what is your a in this equation?
14.
The 14. The initial amount is that number by itself. The number that has the variable with it is called your growth factor. So what is my growth factor right now? 2, yeah. So look at letter B. What is your initial amount? What's the starting amount in that problem? 25,600. What's your growth factor? 1.01. Okay, here's what I want you to think. The number 1.01 is basically saying it's 101% of what it started as. So after 1 year, it's 101% of 25,600. After 2 years, you take it to the second power. After 3 years, you take it to the third power. So this is 101% each time that we're growing. All right, letter C. What is your initial amount, your starting amount? The 150. So you're starting with 150, whatever it is we're talking about. What's your growth factor? 1.0894. This one looks different. What's 0? Is 0? Well, let's think about it. If A is 0, then f of t equals what right now? If there's a 0 right here.
Is it 1?
Then it equals 0, which doesn't work because we know it equals 1.4 to the t power. So instead of a 0 being there, it should be a 1 right there. So while there isn't a 1 written there, it's as if there is a 1 there because the formula would be f of t equals a times b to the t power. Well, a then has to be 1. And b is whatever is taken to the power, which in this case is 1.4. Does that make sense?
Yeah.
Okay, so if you only see one number there, it's the a that's missing, and that a should be 1. Okay. I'm trying to decide if I even, I did it this way, but I really want to do it a different way. I really do. Okay, here's what we're going to do. We're going to scratch this for now. I'm going to give you a different equation. Whenever you see a percent in the problem, and it is exponential growth. Okay, with exponential growth, here is the equation that you're going to use. It's going to be y equals, you'll still have your a, which is your starting amount. And then it will be 1 plus r, and you will take it to the t power. Okay, here's what I need you to understand about this. A is still the initial amount. R is the rate or the percent as a decimal. T will be time. Okay. This is the formula that you're going to use whenever there's a percent in your problem. So if you see a percent in your problem, use this one. You can use the other one, but you have to understand it a little deeper to remember how to use the other one. This one kind of does the work for you a little bit more. So R stands for a rate or a percent. Let's take a look at this. If this is my formula, first of all, any thoughts as to why this is 1 plus that R? Look at this problem. It says, suppose since 2020, the amount of money spent at restaurants in the U.S. has increased about 7% each year. In 2020, it was $360 billion. If that continues, what would it be in 2030? It's saying it increased 7%. So if I want my 360 billion to increase by 7%, what percent do I want? It started as 360. I don't want to go down to just 7% of that 360. I want that 360 plus 7%, right? I want to increase by 7%. So what percent do I actually want of my original?
7.
Not 7%. I want 7% more. So what's 7% more than what it started as? It started as 100% of what we had, right? 100%, the whole thing.
107.
Now it's 107%. So that's why we add 1, because we're going to treat it like a decimal. 1 plus 0.07 is the number 1.07. That, as a percent, is 107% of what it started as. I feel like that is the tricky part for people to wrap their brains around sometimes. So just make sure if there is a percent in your problem that you are setting it up with this equation, because then it's going to add that 1 for you so that you don't take it down to 7% of what it was. You add 7% to what it was. Okay. Let's see if we can set this up. So if this is my equation, y equals a times 1 plus r to the t power. Your equation would be y equals, what is a? What? 360 billion. Don't write it as billions right now. Just write it as 360 and tack on a billion at the end when you write your answer. So we're going to go 360 times, this will always be a 1. You're going to go 1 plus, because we're increasing. And then we said our R is a percent as a decimal. How do you write 7% as a decimal? 0.07 to the t power. So this is your equation that you're working with. You are welcome, if you want, to call it y equals 360 times 1.07. Just add those together. I like it like that. But if you leave it like this, it's not wrong. What are we going to plug in for t? What is our time? 10 years. Don't plug in 2030. That's a very large, that's saying 2030 years after we started this, which is not true. If it started in 2020 and we want to know in 2030, that's 10 years later. So you're going to plug a 10 in right here. So plug that into your calculator. 360 parentheses 1.07 parentheses to the 10th power. And what do you get? Point a lot of different things, yes. So it's this number, 708.174. It just keeps going, okay? I'm going to say it's approximately, tell me what that means.
Like about
Yes, sorry. Tell me what this means. My bad.
the growth.
What?
Wait, what?
What does this mean? 708 what?
How much?
$1 billion. $708 billion. They were talking in billions, so this is about $708 billion. Okay. Okay. Here's your second problem, and I'm going to have you try it on your own or with a neighbor is fine. But see if based on this formula, so you're going to use, oh, come on. You're going to use this formula again. Actually, we'll just rewrite it. Y equals A times 1 plus R to the T. See if you can plug that in and see what you get.
What? You can read this, the initial amount. I didn't see it. But it's like, what's going, how it's. I just did that one. I stopped looking at this.
So points, that's fine, but otherwise, yes. Okay, did you get a value?
Yeah,
Yeah, what's your number?
I said about 4,887.
Did anyone else get 4,000 something?
Yeah.
Did anyone get 43,000 something? Okay, I know what you did if you got the 4,000, and it happens all the time. Let's take a look. What is your A?
What was the right answer?
I'll tell you in a minute.
285.
I'll talk you through it. 285 is your starting amount. So there's 285 cell phone subscribers. It increased by 75%. What is 75% as a decimal? 0.75, not 7.5, not 0.075, right? Just 0.75. So 1 plus 0.75 to the T. Okay, so that's your equation. You're going to plug in what number for T? 1.75 to the 9th power. Plug that into your calculator. You should be getting this. If you got the 4,000 instead of the 40,000, your decimal point moved to the wrong place. Be really careful when you turn 75% into a decimal. 1, 2 goes right there. 0.75, not this. Not this.
I just
Two
forgot
places.
to write down something I got.
Okay. Yes.
How do you read the decimal?
How do you what? How do you read it? Well, so I would say for my answer about how many cell phone subscribers were in the small town in 2023, this is talking about people. You can't have a fraction of a person or a decimal with a person. So if you told me it's about 43,872, we'll say subscribers, because that's the word they used, subscribers, that would be great. If you want to argue that you haven't made it to the next one, you could call it one. How do I, what?
Like, what does it say?
43,871.986? Is that what you're asking me? Yeah, like your answer is not this. Your answer is this. Round it off, because you can't have a decimal for a person. So just call it about 43,872.